Okay, so next topic natin under the dynamics of rigid bodies is yung tinatawag nating motion curve or yung motion diagram. So again, just like what I've told you last time, so same application lang din naman siya nung shear and moment diagram. Okay, so let's start. So motion curves. So in this session, you will get to know more about the concept of dynamics of rigid bodies and other engineering science. By the end of this session, you should be able to, number 1, analyze non-uniform acceleration motion by graphical solution. So, when a particle has erratic or changing motion, then its position, velocity, and acceleration cannot be described by a single continuous mathematical function along the entire path. Instead, a series of functions will be required to specify the motion at different intervals. So for this reason, it is convenient to represent the motion as a graph. Okay guys, so just like what I've said before, pwede mo rin namang kasi siyang computein using the formulas do sa rectilinear translation. Kaso nga lang, ilang set of equation yung gagawin mo para mahanap mo yung unknown o yung nire-require dun sa problem. So, for example, ilang beses mong gagamitin yung isang formula. Okay? Kasi nga, at a certain period of time, meron kang, for example, meron kang ganitong acceleration. And then, yung sumunod na time, walang acceleration. Tapos, do sa last, magkaaroon ka ng deceleration. So, kapag ganun daw, guys, yung mga problem, or sinasabi nga dito, when the particle has a changing motion, it is better to represent that as a graph. So, dyan papasok yung motion graph natin. Okay? So, kung maaalala nyo, yung ating shear and moment, di ba ang pinakasimulang diagram yan is yung beam mismo na ina-analyze natin? And then, ano yung sunod sa beam? Di ba papasok dun yung shear diagram? And then last will be the moment diagram. Ngayon dito naman sa motion graph or itong motion curve, ang mangyayari, ang unang diagram mo will be the acceleration diagram. And then followed by the velocity diagram. And then last will be the displacement diagram. So guys, sa y-axis mo, andyan guys yung inyong acceleration. And then sa x, dito nakalatag yung time or yung interval t, time interval. And then for the velocity, again, basta tandaan nyo lang lagi na yung sa x mo nandyan yung iyong time. Okay, so sampulan natin. For example, ang i-consider natin is yung SI unit, which will be in meter per second squared. So in time natin, ang unit niya is in seconds. Okay? So, ang sabi dyan, if you're going to solve for the diagram or the velocity at a certain time t, ang mangyayari dyan, that is just the area of the A versus T graph or yung area na tatamaan nito. So, for example, dito, meron kang strip. So, that strip is considered as a dt, which is papatakbuhin mo from T1 up to T2. Kung saan, at T1, meron siyang certain value ng acceleration. And T2, ganun din. Meron din siyang corresponding acceleration. So, if you're going to integrate that, okay, so mapapalabas mong equation is ito. So, that is V2 minus V1 is equals to the area of the acceleration graph or diagram. So, check natin if tama ba. So, for example, this is a rectangular shape. Ayan. So, for example, binuo ko lang na ganyan. Okay? Kung saan ito, yung height niya dito, or yung acceleration value niya, i-denote na lang natin as A. And then this one, i-denote natin as A. Okay? And then yung time dito, so i-denote natin to as time T. So, ano na buo nating shape? Diba? Rectangular or square? Okay, so ang sabi, yung velocity mo dito, yung sa katapat niya dito. Kasi gagawa nga ng parang shear moment diagram, di ba? that is equals lang daw sa area na ito. Kung saan that is equals lang sa area, sorry, the acceleration multiplied by the time. So yan daw yung velocity mo dito sa time, yung v2. Okay? Kasi kaya yan v2 minus v1, meron kasing cases na meron kang initial velocity. Okay, merong value yung v1. Pero mostly, itong v1 mo, this is usually 0. Pero on other books, on other problems, depende sa problem, merong binibigay minsan na initial velocity. Okay, so acceleration times time, ano nga yung ating di ba area lang nito, itong rectangular shape na yan. So di ba ang unit mo ng acceleration is meter per second squared. And then yung unit mo ng time is seconds. Which is ma-cancel lang yung isang seconds, ito bawasan mo ng isa. So meter per second. So na-satisfy natin yung unit. Okay? Which is yung velocity mo nga is distance over time. Okay? So ganun din, kapag yung displacement naman ang ipapahanap sa'yo, so ito yung magre-represent na parang moment diagram sa shear and moment. So saan ka nakabase sa moment diagram? Di ba dun sa shear? So kung displacement yung hinahanap mo ngayon, so ang i-consider mong diagram is itong velocity diagram. Okay? So area lang yan ang VT diagram. So try ulit natin kung masasatisfy natin yung units. So ano nga yung unit natin velocity? That is meter per second for SI, and then yung time mo. So that is time. Seconds. So for example, di ba ito is a rectangular shape. So dito papasok din yung ruling na doon sa susunod mong diagram, lagi ka madadagdagan ng 1 degree, or knowing that yung rectangle mo is a 0 degree curve. So ang sunod niya magiging shape is a 1st degree curve. So it's either triangle yan or anong tawag dito? Trapezoid yung magiging shape niya. So for example, i-consider na lang natin na let's just say na gumawa tayo ng panibagong diagram. Kung saan yung nabuong diagram coming from the acceleration diagram. So nakabuo tayo ng shape na triangle. So ang nito, sabihin na natin na itong height na yan. So yan yung velocity. And then ito will be the time t. So nagsasample lang tayo hindi pa talaga ito yung i-dinidiscuss ko lang yung magiging concept natin sa Okay. So to know the value of your displacement, so di ba S2 minus S1 is equals do sa area lang ng shear diagram. Sorry, napapag-ano ko na. Not shear, the velocity graph. The velocity time graph. So para makuha yung area niyan, di ba yan ay area lang ng isang triangle, or that will be 1/2 of the velocity times time. Okay? From which, yung velocity mo nga, di ba ang unit niya is in meter per second. And yung time mo is in seconds. So cancel. So mapapalabas na ating unit is in meter, or that is a unit of displacement, or in distance, S. Okay? So coming from a 1st degree, so ganun lang din. So after nito, ano yung susunod nating diagram again? So di ba ito is velocity diagram. And then ito will be the displacement. So, i-apply mo rin yung tinuro ko dyan sa inyo before sa deformable bodies na yung maximum minimum. So, di ba between the preceding value, which of these two value is the maximum and minimum value? Disregarding the sign. So, kung negative yan, i-neglect mo muna yung negative sign. So, ito, di ba, 0, ito, value na V. So, di ba ito yung minimum, and then ito, yung maximum. So, pag-connect mo lang yan. Ayan. So, coming 1st degree, this one will be the 2nd degree curve. Okay, so aside from that, meron din ilagay dito na equation. But then again, hindi na tayo gagamit nito. Okay? So, ang i-apply na rin nating method dito is yung kapareho nung sa deformable, yung titig method. So, magbe-base lang tayo, tititigan mo lang, and then i-consider natin yung area. Hindi mo na kailangang pahabain ng ganito, yung isusulat mo pa yung equation ng mga area, ma-minus mo dito. Since yung time nga natin, lalo yung pang Monday to Thursday, is 1 hour lang. So, sa exam, baka magtagal pa. So, idiretso na natin yung shortcut method o yung tinatawag kong ang titig method lang. Okay? And then, ito rin yung isinama rin dito yung mga general equation for the area of a rectangle, triangle, parabolic spandrel, and cubic spandrel. Pero guys, di ba may tinuro rin naman ako sa inyo before yung general equation for a nth degree curve. So, ganun na lang ulit. Knowing na ito, ilet mo to as your n or yung degree ng curve mo. Ano bang ginawa niya dito? So, ito, yung h mo. And then ito, yung base. And then yung c, yung centroid. So, ilet natin to as c na lang din. So, di ba yung general formula for area? So, that is 1 over n plus 1 multiplied by b h. Okay? So, kung triangle yan, that is a first degree. So, that will be 1/2 of the base times the height. And then, yung para sa centroid natin, so that is equals lang sa b over n plus 2. So, kung triangle ulit yan, di ba, that will be 1/3 of the base, which is correct naman, di ba? So, ito na lang guys yung tandaan nyo. So, parang hindi na kayo magsulo sa ulo ng sobrang daming formula. Okay, so this is an example. So, i-analyze lang natin ito. So, shown dito is yung, yun nga, yung pagkaasunod-sunod. So, imagine mo na lang ulit na ito yung beam mo. Followed by the shear diagram. Ayan, so yung shear mo naman is parang ano din, di ba? Yung symbol niya is capital letter V. So, parang velocity rin siya. So, pwede mong gawin palatandaan yun para hindi na kayo magkapalit-palit. Tapos, yung x mo, so dito inlet nyo lang x yung displacement. So, yan yun din yung displacement s. So, ito yung magiging parang pinaka-moment diagram. Ayan. So, analyze natin yung graph. Wait lang check ko lang doon sa OBS. So, ilayo ko siya para at least kita rin yung acceleration diagram. Ayan. So, drag ko lang ng konti dito. Okay, so, yung pag-a-analyze guys ng ganyan, discuss lang natin ng konti. Kung mapapansin nyo dito sa displacement diagram, ayan, yung mga distance. Yung iyong, dito sa part na to, ayan, versus dito sa shear diagram. So, since this is a increasing slope, it indicates that the velocity is also increasing. Ayan. So, since pataas yung value niya, ibig sabihin yung velocity niya dito is also increasing uniformly. So, under a first degree. And then next, kung mapapansin nyo dito sa sunod, eto. So, ito merong constant slope or yung degree niya is a first degree, meaning that doon sa preceding diagram mo, which is the shear, meron kang uniform velocity. So, hindi siya nagbabago or horizontal line siya. Zero slope, which implies that zero yung acceleration niya dito. Kasi wala kang pagbabago doon sa velocity nga eh. Di ba kapag there's no change in velocity, wala kang acceleration, which is correct naman, di ba? Ayan. So, dito sa part na to, ayan. So, yan is constant slope. Meaning, yung velocity niya is also constant. Next, under this part, so, magiging shape niya is parang paganyan. So, ibig sabihin yan, guys, yan ay decreasing yung slope niya. Which indicates that the velocity is also decreasing. Okay? So, mapansin nyo dito, ayan. So, coming from this value, and then nagpunta siya doon sa zero velocity. Ayan. So, decreasing naman talaga. And then, if mapapansin nyo doon sa acceleration niya, so, hindi na siya acceleration ngayon. Negative value. So, at this portion, deceleration siya. Okay? And then dito, di ba dito sa peak natin, or dito sa maximum value ng iyong displacement, meron kang horizontal point dyan. That is zero slope, which implies that zero yung velocity natin dyan, which is correct, di ba? Pagdating niya dito, nag-zero velocity siya dun. Okay, so, and the next, ganun din, eto, decreasing din yung slope niya, or yung shape niya is pa ganyan. So, meaning, if you're going to consider the velocity diagram, that is also decreasing. So, mas lalo siyang bumagal. Coming from a zero velocity, naging negative yung velocity niya. Okay? And then, at this point, eto. So, dyan sa point na yan, ano na siya, nag-flattening na yung curve niya. Which implies that yung velocity mo, velocity becoming less negative. Or, babalik na siya sa positive value. Okay? So, coming from this point, ayan. So, pumunta siya dun sa zero. So, coming from a negative value, approaching na siya dun sa positive value. Okay, so, ano rin naman yan, again, application lang siya nung maximum minimum kapag pa ganito yung curve. Ayan. So, this is increasing, ito decreasing. Sad pace. Ewan ko na-discussan niya ni Sir Jake yung ang ginagamit niya kasi is yung sad pace at saka yung smiling pace. Smiling pace, increasing. Sad pace, decreasing. Yung akin, siya rin naman yung nagturo na, no? Yung maximum minimum value. So, pag maximum, yung vertical line, minimum is yung minimum value. Okay, pero ganun rin naman yun. And then, dito sa point na to, ayan, horizontal line. So, that means that yung iyong object continuing zero slope, which implies that the object is at rest na. Or, kung mapansin nyo doon sa preceding diagram, yung velocity niya is zero na. Which means, if zero na yung velocity mo, the acceleration is also zero. Okay, so mas mamaintindihan nyo naman to kapag nag-solve tayo ng mga example. So, let's start first with problem number 1. So, gamitan natin siya ng application ng rectilinear translation at saka ng motion diagram or motion curve. Okay? Okay, so let's read problem number 1. So, an automobile starting from rest, speed up to 12 meter per second with a constant acceleration of 1.2 meter per second squared. So it runs fast speed for some time and finally comes to rest with a deceleration of 1.5 meter per second squared. If the total distance traveled is 300 meters, so find the total time required. Okay, so just like the previous module, so ang ano mo kasi dito, since kung mapapansin nyo, walang graph na binigay, we need to interpret first the problem. Okay, so ang unang approach muna natin gagawin guys is yung motion curve. Okay, so again, yung una mong graph na ipla-plot is yung para sa acceleration. So gawa lang ako dito. Ayan. So, yung first quadrant naman yung ginagamit lang natin dito, di ba? Ay, may ano pala. Masasakop rin pala yung fourth quadrant. Kasi, meron ditong deceleration. Ayan. So, sige. Basahin natin. So, an automobile starting from rest speeds up to 12 meter per second with a constant acceleration. Okay. So, itong term na to, itong constant acceleration, napakahalaga nyo. So, kapag constant acceleration, guys, yung acceleration diagram niya is a 0 degree curve. Okay? O rectangular yung magiging shape niya. Okay? So, i-plot ko lang ito para at least so, tumakbo siya. Speed for some time. So, mahati siya to 3 segment. Okay? Ayan. So, i-plot ko na rin dito guys yung shear diagram. Sorry. Velocity diagram. Sorry na paglilituhan ko lang na. At pareho kasing V. Ayan. Velocity diagram. So, an automobile starting from rest, ayan. So, ibig sabihin, when you start at rest, the initial velocity at this point, yung sa time 0, so that is 0 meter per second. So, speeds up to 12 meter per second. So, coming from a 0 degree, so alam natin na magiging ganito siya. First degree. Na ang value niya dito is 12 meter per second. Hindi ko na isusulat yung meter per second. Understood na natin na ganyan siya. Itong acceleration is meter per second squared. Okay? Then, it runs at a fast speed for some time. So, ibig sabihin, ayan. So, it remains at the same speed for some time. So, ibig sabihin ito, magiging T1. Again, yung x-axis natin is yung seconds. And then ito, T2. And then this one will be T3. Okay? To travel for some time at a constant velocity. Then, finally, it comes to rest with constant deceleration, with a deceleration of 1.5 meter per second squared. So, meaning at this point, ayan, so nasa ilalim siya kasi deceleration na, or negative value siya. So, this is negative 1.5. So, itong una, ano ba yun? 1.2. So, this is 1.2. Okay, so, it comes to rest. So, meaning, yung final velocity niya, nung ma-reach niya yung T3, so that will be 0. Okay. So, extend lang ulit natin to. Ayan. So, yung last graph natin will be for the displacement S, which is in meter. So, ang gawin natin, i-graph muna natin yung displacement. Kasi sabi dyan, yung total distance travel daw niya is 300 meter. So, at this point, dito sa dulo, dito sa may time 3, ang value niya ng displacement dito is 300 meter. So again, based dun sa velocity graph, so between these two value na 0 and 12, which is the maximum and minimum. So ito yung minimum, ito yung maximum value. So ayan. And then, since ito is rectangular, so magiging first degree curve siya. So, pangalanan na lang natin muna to as S1. This one as our S2. And then, yung S3 natin, so, this is maximum, this is minimum. Ito ko na lang pala ilagay. Ayan. So, that is 300. Okay, so I think na-plot na natin. We can now solve the required. So, unahin natin itong para dito sa shear. Again, yung shear mo is i-ano natin yung conventional solution. Di ba yung shear, or ito yung magiging V2 natin? So, that is 12 minus 0 is equals lang do sa area nitong diagram natin na ito. Okay? Or that is 1.2 multiplied by T1. Okay, so baka magtaka kung paano nakuha to. So that is yung V. Ano ba natin to? Yan. So gawin natin to as V2 and V1 and V3. And then ito gawin natin V4. So, pakita ko lang yung yung solution na mahaba. Pero again, sabi ko nga, pwede naman tong titig method na. Pero sa una, ipakita muna natin. So, ito yung S3 natin. So, this is acceleration 1. And then, ilat na lang natin ito as acceleration 2. Okay, so that is V2 minus V1 is equals to yung area nga. Area nung 80 diagram. So that is yan. So what will be the value of T1? So that is simply equals lang sa 12 over 1.2, or that is equivalent to 10. Tama ba? Okay, calculate na natin para sure. Ayaw gumana. Para sure, baka mag-iba ang sagot. Sabi ko sa inyo eh. Oh, no. Tama, 10. So that is 10 seconds. Okay, ano bang hinahanap? Find the total time required. Okay, so ang kailangan pala natin malaman is yung T1, T2, and yung T3. Next, para doon sa T2, so paano natin siya mako-compute? So wala naman tong area. Okay, so let's consider first these values. So ang gagawin natin, considering the displacement at 3, which is 300, and knowing na ito yung kanyang shear diagram, so mako-compute natin yung kanyang time 3. Okay, so let's consider this portion. Ayan. So yung S3 mo minus S2, so that is equals lang do sa area ng velocity diagram, or that is 1/2 of B3 times time 3. And knowing that yung ating S3 is 300, wala pa rin pala tayong time 3. Okay. So, kulang pa tayo ng time 3. Ibig sabihin, guys, kailangan pala muna natin makuha tong shear. Considering this shear and yung kanyang acceleration. Ba't ako puro shear? Velocity. Okay, so ito muna pala yung consider natin para mahanap natin yung kanyang time 3. Okay? So, pagkakuha natin kayong time 3, tsaka natin siya i-apply dito. So, ito muna. Guys, dito ko na lang sulat sa baba. So, that will be 0, yung B4, minus B3, is equals lang sa area ng iyong acceleration diagram. Kung saan ito nga is negative value. So, that is 0, tapos minus 12 is equals sa area nun, which is 1.5 times T3. Ayan. So, ito muna pala kayong kailangan natin i-consider. Parang mahirap to gawin sa rectilinear translation. So, that will be 8 seconds. So, since meron na tayong isa pang time, ayan, makukuha na natin yung S2 natin. So, that will be 1/2 of the velocity 3, which is 12, times T3 na 8 seconds. Okay? So, magkaaroon tayo ng value ng S2. So, that is 12 times 8 divided by 2. So, 48 transpose. So, 300 minus answer. So, that is 252. Okay, so lagyan na natin to ng value, 252. Ito, check na. Check. So, ano na lang kulang natin, guys? So, itong S1, still unknown, and yung T2. So, paano natin makukuha yan? Okay. So, para makuha yung value ng T2, diba ito, T2 lang din. Okay. So, i-consider nating point is itong sa displacement S, at saka yung versus dun sa iyong velocity diagram. So, itong segment na to. Ayan. So, i-highlight natin para hindi malito. So, ito, tsaka itong mga values na to. Okay, so, sabi nga, do sa formula, yung displacement displacement mo 2, so S2 minus yung S1 mo, so that is equals lang dito sa area ng velocity versus time na graph. So that is 252 minus S1 is equals dito sa area nito. So that is 12 times T2. Ayan. Wala pa akong S1. Pero wala pa tayo guys S1. So paano mo compute yung S1? So para ma-compute yung S1, ito muna pala yung kailangan natin i-consider. This one, tsaka ito. Kasi meron naman akong time T1 na na-compute natin kanina, which has a value of 10. Okay, so unahin muna pala natin to. So ang mangyayari, so that is S1, so minus 0 is equals lang sa area nito, area ng velocity time graph. So S1 is 1/2 of the base T1 na na-compute natin kanina as 10 seconds multiply by 12. So your S1 will be, so 120 over 2, so that is 60. And then tsaka pa lang natin pala masosolve to. So 252 minus 60 is equals to 12 times T2. Chika lang palang mas madali rin yung motion curve. Baak-baak nga. Pero may mga madaling problem to eh. Nagkataon sigurong mahirap agad yung napili natin. So, minus 60 divided by 12. So, the time 2 is 16 seconds. Okay? So, ano ba required? Total time required. So, yung total time natin, so that is simply equals lang sa summation ng T1 plus T2 plus T3. Or that is equals to 10. Saan yung T2? So, plus 16. And then plus 8. So, the total time required is 10 plus 16 plus 8. 34 seconds. Okay guys, so I will give you again 2 minutes to copy. So you may start copying the problem. Habang ina-analyze ko if pwede siyang applyan ng rectilinear na formulas. Okay, so let's proceed muna dito sa problem number 2. A car starts from rest and reaches a speed of 48 meter per second in 15 seconds. So the acceleration increases from 0 uniformly with time for the first 6 seconds, after which it remains constant. Okay guys, so para do sa pangalawang sentence, napakahalaga nitong word na to. Ito yung magbibigay sa atin ng idea kung paano yung magiging shape ng kanyang acceleration diagram. So sabi dyan, it increases from 0 uniformly with the time. So magiging shape niyan is a triangular shape, no? So from 0 up to a certain value of acceleration for the first 6 seconds, and after that, which it remained constant. Then, nung ma-reach na yung acceleration na yun, it remained constant all throughout dun sa motion natin hanggang ma-reach na yung 15 seconds. Okay, so which of the following gives the constant acceleration? Letter B. Which of the following gives the velocity after 6 seconds? And letter C. Which of the following gives the distance traveled in 15 seconds? So again, ang maganda dito, i-drawing muna ulit natin yung kanyang acceleration diagram. Okay, so again, gawa ka muna ulit ng X and Y. Ayan, so we will denote this as our acceleration diagram. Again, its unit is in meter per second squared. And yung X will be the time T, which is in seconds. Okay, so i-plot mo yan again. The acceleration increases from 0 uniformly with time for the first 6 seconds. So it should be straight. Ayan. And then, eto nga, sabi dyan, so at the first 6 seconds. And after which it remained constant. So knowing that yung total time ng motion natin is 15 seconds. So 15 minus 6, so that will be 9. So from here up to here, so uniform na yung acceleration. So hinahanap pa siya, so let's say that that value is equals to acceleration. Again, this is still unknown. So hanapin natin. Next, again, ang kasunod ng acceleration diagram is yung ating velocity diagram. Ayan, hindi na ako nagkamali, hindi na shear. So yung velocity mo is in meter per second. Again, all x-axis, that will be in time, which is in seconds. So a car starts from rest and reaches a speed of 48 meter per second in 15 seconds. So magiging itsura ng kanyang diagram. So after 15 seconds pa yun. So ibig sabihin, dito pa siya sa dulo. Ano? So dito pa niya ma-attain yung 48 meter per second. So in short, ang magiging shape niyan is pa ganito. So i-project ko lang to. So alam natin na ito is a positive acceleration. So tataas siya dito. Ayan. Oh, sorry. Ayan. So this is the first degree. So ito, hindi pa natin to alam. So i-denote na lang natin to na velocity at 6 seconds. So this one is the velocity after 15 seconds, which is 48. And then, sabi nga, starts from rest. So ibig sabihin, it will start from a zero velocity. So this will be minimum, maximum. Ayan. So pag ganyan yung shape niya. Positive slope. So first degree sa velocity at 0 second is 0. Ayan. And then last natin, so this will be the displacement S, or yung the distance traveled. So the unit will be in meter. Again, all x is in seconds. Okay, so ganun lang ulit. Project lang natin. Again, wala pang hinahanap dyan. So, I think minimum, maximum. So, this is ayan. So, this will be second degree. So, minimum maximum. Sorry, this is second degree. And then this one, this will be a third degree. So this is the second degree. So denote na lang natin to as S15 or the displacement after 15 seconds. This one, displacement after 6 seconds. Ayan. So ito, displacement at 0 seconds. So obviously that will be equals to 0 since wala pang ang motion na nangyayari. Okay, so ano ba ang una nating mahanap dito? Velocity ng 15. So unknown. Velocity of 6 with 0. Okay. So ang gawin natin, ito, this portion muna. Siguro highlight ko na lang siya ng pula. So ito muna yung analyze natin. Makakakuha tayo ng equation ng velocity 6 with respect to acceleration A. Ayan. So from 6 seconds to 15 seconds. Okay? So the velocity 15 seconds minus the velocity at 6 seconds is equals lang do sa area. Sa area ng 80 diagram. So from 15, 6 seconds. So we have here a value of 48 and then this one, so this is V6. And then this one, so this is A multiplied by 9 seconds. So the velocity at 6 seconds is 9A. Gawin ko palang ganito yung area, acceleration. So 9A, sorry, transpose. Ganito pala siya dapat. So 48, transpose mo doon, minus 9A. So this will be our equation 1. And then next, I consider natin yung from so ito guys is yung from 0 to 6 seconds or itong portion na to. Okay? So that will be velocity at 6 seconds minus yung velocity at 0, which is 0. And then that is the area of the 80 diagram from 0 up to 6 seconds. So kailangan mo pala talaga sigurong isulat yung equation kapag ganitong motion curves. So yung titig method, applicable lang siya sa pag-draft or yung paggawa ng acceleration, velocity, and displacement diagram. Pero yung solution niya talaga, kailangan mong baak-baakin na ganito. Pero doon sa last example, I think pwede nating i-apply doon yung titig method. Kasi given na lahat doon sa acceleration diagram. So ang hinahanap lang doon is yung velocity at displacement. Unlike dito na binigay yung velocity, may time, pero wala ang acceleration. So parang pabalik yung nangyari. In short. So ang gawin natin, since meron nga tayong equation for V6, yung nakuha natin for equation 1, substitute natin siya dito. Okay, so ang mangyayari, that will be 48 minus 9A is equals do sa area ng acceleration diagram, which is equivalent sa 1/2 of base, which is 6, and then times A, yung acceleration natin. Okay, so transpose mo lang. So that will be 3, then plus 9A, so that will be 12A, and then 48. So our acceleration, so 48 divided by 12, so that is 4, so that is meter per second squared. Iba yung nahanap sa A. Okay, so we're done with A. Next, ano pa bang required? So which of the following gives the velocity after 6 seconds? Ayan, so substitute mo lang dito sa nakuha natin. So for letter B, so since nakapag-drop na tayo ng equation for the velocity at 6 seconds, so that is simply equals lang sa 48 minus 9 times the acceleration, which is 4. So the velocity after 6 seconds, so that is 48 minus 9 times 4 is 36. So that is 12 meter per second. So 12 meter per second. And then last, which of the following gives the distance traveled in 15 seconds? Okay, so I think, ayan, area na lang to. So yung for letter C, yung displacement niya after 6 seconds is just the area of this shear diagram. So pakita na nga natin. So area of VT diagram. So from, ano time yun? 0 to 6. So 1, so that is a second degree curve, so that is plus 1, so magiging 1/3 of the base na 6, and then the height na V6, which is 12. Displacement after 6 seconds, so 12 times 6, and then divided by 3, that is 24 meter. So hindi pa tayo tapos. Again, ang hinahanap is yung para sa 15 seconds. So para makuha yun, so again, S15 minus S6 is just equals this area of the VT diagram from 15 up to 6 seconds. So we have S15, so minus 24 is equals to, so ayan, area lang ng trapezoid, or that will be H over 2 or 9 over 2 multiplied by the quantity of base 1 plus base 2, which is 48, and then plus 12 or yung V6. So the displacement after 15 seconds, lang natin sa calcu, 9 divided by 2 times the quantity of 48 plus 12, and then transpose mo sa kabila, so plus 24. So that is 294 meters. Alright. So guys, again, please copy. I'll give you 2 minutes to copy the solution.
Okay? 5 by 10. So ang gawin ko na lang, i-transpose ko siya doon sa kabilang side ng equation. So magiging positive siya or magiging ganito yung equation. Okay? So equals to R2 times 10. Therefore, R2 will have a value of, so gamitan na natin ang calcu. Ayan, wala pala yung calcu natin. So ito. So 300 times 2 plus 600 times 7 divided by 10. So the answer is 480 pounds. Okay, next. After taking summation ng moment at A, mag-moment naman tayo sa B para mahanap natin yung reaction 1. Ganun lang ulit. Take summation ng moment at point B equals to 0. So ngayon, dito naman tayo sa point na ito magpapaikot ng mga force. So unahin natin yung R1. Anong moment na na-produce ng R1? Clockwise, diba? So positive. So 10, the perpendicular distance sa 10, times R1, and then yung 300 pound. Okay? The 300 pound will produce
Sa deformable bodies nyo kasi, pwede kasi ganito yung solution nyo kay ano, shear and moment. Pero sobrang haba naman kasi.
minus 2, so that will be,
Pero sa libro, ganyan talaga yung ano din. Parang ganito din yung ginagawa.
ayan, kinukuha natin.
Kaso nga doon, since, ayun nga, nagsisimula tayo doon sa beam,
And then yung 600,
sunod-sunod
so
na siya.
minus din, since counterclockwise moment will
Pwedeng yung titig method. Dito kasi, anong nangyari nga, meron kasing velocity after 48 seconds. Tapos lahat ng merong data dun sa acceleration diagram na wala yung acceleration. So, anong nangyari nga dito, parang
Okay, so transpose mo lang
naging pabalik. So, kailangan mo palang talagang isulat muna yung equation para mahanap mo yung mga unknowns dun sa pinaka-top diagram niya, which is the acceleration diagram.
plus 600 times 3.
Pero dun sa susunod na problem, I think it's the last problem. Given lahat yung data niya sa acceleration.
Okay, so this time,
Dito.
gamitan natin ang option.
So, mangyayari, yan, pwede mo nang apply yung titig method ngayon. So, ang sunod sa acceleration, velocity nga, tapos displacement. So, kompleto yung even sa acceleration. Ang mga unknown is yung sa mga susunod. So, applicable yung kahit tigan mo lang. Kahit wala na itong mga sulat-sulat na yan. Makukuha mo yung shear na naman. Yung velocity and yung displacement. Okay. Alright, so putulin muna natin dito then sa second video. So that will be for the solution part na problem number 3 and ito nga, yung problem number 4. Ayan, so tama. Kompleto lahat ng data.
The equation will be
Okay,
R1
so
plus R2
see you sa part 2.
minus, since bababa yan, 300 siya into a single force.
Guys, alternative solution lang tayo. Kung maalala nyo kanina, di ba sabi ko, pwede rin kasi natin itong applyan na principle or concept ng rectilinear translation. But, applicable lang siya kapag yung acceleration mo is uniform. So, dito lang siya sa part na to, gagana. Dito, okay? Kasi, acceleration niya during from 6 seconds up to 15 seconds is constant na 4 meter per second squared. Pero kapag yan is uniformly varying or increasing from 0 up at a certain value, so hindi mo pwede gamitin yung principle na rectilinear translation. Again, under rectilinear translation, constant yung acceleration niya lang dapat. Okay, so pakita natin yung alternative solution. So I think gagana naman to dito kasi nga constant yung acceleration niya. So ang gagawin ko, kukunin ko yung distance na matatravel niya from 6 seconds up to 15 seconds or during this 9 second na span. So, di ba alam natin that yung ating formula for S or yung displacement na to S, sabihin na natin itong S2. So, yung S2 natin, we have an equation for S2 as VOT plus 1/2 of AT squared. So, ang initial velocity na i-consider mo dito is ito, yung V6. Kasi nga, itong span na to yung i-consider natin. And knowing na ito yung simula niya, and then ito yung magiging final velocity niya. And even yung isang formula, pwede mo rin gamitin yung BF squared, BO squared, plus 2AS. So, sure naman na pareho lang din yung lalabas dyan. Pero since alam rin naman natin yung time, ito na lang yung gamitin natin. Okay?
Will be 90 minus theta.
So, S2, so ayun nga, initial velocity, yung velocity niya at 6 seconds, which is 12, multiplied by the time, na 9 seconds, plus 1/2 of the acceleration, which is equivalent to 4, times 9 squared. So, what is the displacement during the 9 second span? So, ngayon lang natin yung calcu.
Ano bang gusto niyong gawin natin dito? So, either of these two naman eh. Pwede.
So, nung nirib ko pala yung video kanina,
RBX, as you can see here,
hindi pala gumagana yung calcu.
wala siyang perpendicular distance.
Naka-freeze siya. Pero inayos ko naman ngayon. So, ito gagana na siya.
Kung mapapansin mo, mahanap natin yung
So, doon sa naunang part, I hope sinasabayan nyo akong pumindot doon para at least na nakita. So, that is 270 seconds. So, that is only for S2 pa lang ha. How about for S1? Paano natin siya makakompute? Ang gagawin mo dyan, yung area lang talaga nito. That's your only choice for that. Which is, nakita natin na 24 seconds. So, ayun. So, if you're going to compute for the total displacement travel during the 15 seconds journey, so that is 24 plus 270. You will arrive at the same answer then, 294 meter. Okay? Kasi kung titingnan mo to, ang nangyari kasi sa equation na to, parang naging ano siya, moment nung inyong acceleration diagram. So, paano ba nasabing moment? So, di ba ang hinahanap is yung displacement at 15 seconds? So, para magiging reference point po ng moment is ito. Tapos yung moment mo tong rectangle na to, di ba? Ang center niya is nandito.
Okay, so we all know that this is 20.
So, alam natin na 9/2 yan, or that is T/2.
By similar triangle lang.
Okay? So, di ba nangyari dyan ay dito?
20 squared. 20 squared.
Area acceleration. Area nito, A times T. Diba? And then multiplied by T over. So, nangyari sa kanya, 80 squared over 2. Ayan. So, and then yung ano niya, babalikan mo kasi yung equation dito kanina. Ito yung sinasabi dito na equation na yun.
400
Ayan.
times
Ito
25.
yun.
And then next, ano pa yung mga forces? Ito 200.
Saan yung B1?
Plus 200.
Which is yung ano natin.
Lahat ng force ba? May nakalimutan. Tingnan nyo mabuti.
Alin ba yung B1? Sorry.
Plus
Ito.
yung 200 na isa, yung nasa gitna.
So yung B1 natin is this 6 seconds, which is 12.
20 plus 20 is 40. And then
Tapos,
plus 200 ulit.
T2 minus T1, or that will be 15
Concentrated naman.
minus 6, which is 9. So, di ba ito yung parang naging ano natin, BOT.
Huwag na natin gawin.
Kaya naging 1 plus 80 squared. Ayan.
So plus 200
Ito rin siya.
times, so 2046 times 60.
So, parang dinerive niya lang
Meron
ulit.
pa bang
Ano.
force? So again, yung RBX mo naman will be concurrent. So wala
Okay,
siyang
so, ayun lang yun. Pero, for this type of problem, kapag pabago-bago yung acceleration, so I think the best approach here is to solve it using motion curves. Okay? So, yun lang. Thank you.